So we've just finished listening to, I think, what's really a remarkable story of technological innovation that has really changed the game in North America for the availability of natural gas. So the topic of this conversation is, okay, we've got all this gas, we've got it at a low price for a long time. What good is this going to do for the rest of the economy? So one of the things interesting about natural gas is, unlike oil, which is primarily used for transportation, or unlike coal, which is primarily used for electricity generation, natural gas is used across the economy. It's used for power generation, it's used for domestic and commercial heating, it's used in heavy industry, and it's even a chemical feedstock. So there are lots of opportunities here in North America, and there are also a lot of opportunities around the world. So that's what we'll be talking about. And to start off the conversation, I thought it would be helpful to hear from each of our guests sort of the perspective, the vantage point they bring to this particular comment. So let's start with David.
Thank you, Sally, and good afternoon, everyone. I come to this discussion from two perspectives, actually. The first is as president and CEO of an energy research and technology company that's on many of the leading edge applications to help benefit the industry and the consumers that it serves. But a different dimension that I'm bringing today also is this position of president of the International Gas Union, or IGU. And just a brief comment about that. The IGU is an association globally of associations, like the American Gas Association, Canadian Gas Association, et cetera. It's been around for 85 years that exists to promote the technical and political and economic interests of the gas industry. Its members cover 97% of the globe's natural gas production, transportation, and use. And many, these days, of our most active members include some of the countries that General Hayden spoke about both last night and today. So it's a very interesting time for the United States for the next 3 years to be leading and serving this global association in light of what's going on in the gas industry globally these days. Geopolitics, low pricing environments, economic unrest, political unrest, and so forth. So it's a very interesting time for us to be in this position. Thank you.
Okay, all right, Michael.
Sally, I'm Mike Farina. I'm with General Electric Company, but my experience in the natural gas industry spans back almost 2 decades. I spent the first decade really on North American gas issues and from a consulting and markets basis. And in the last 10 years, I've mostly done international gas work. And the last 8 with GE across strategic planning, marketing. Today, over the last couple years, I've been really part of an experiment at GE, which is sometimes a dangerous place to be, but it's really exciting. I'm doing development work related to gas to power, where if you look at what GE is doing today in a big picture, GE's refocusing its businesses around the industrial technologies, around digital technologies, and it's taken like the finance business and moved it into really a support role in terms of enabling the industrial businesses. In particular, my focus is on what's happening in the emerging markets. How do we take the technology store, the GE store, and implement it in difficult geographies with good technology, smart structuring, financing solutions. And so for me, it's been taking the markets and the way the world's evolving role into something that's more development. So I'll talk to kind of both of those things, how we see natural gas evolving into the energy mix, and then also how do you get it done in this world today?
Okay, Tom.
Great, thank you, Sally. My name is Tom Jaramillo. I'm in the Chemical Engineering Department at Stanford University, and our interests are very much in energy. And my research lab is pretty much entirely devoted to solving problems in energy, a lot of it with renewables, but now growing more into conventional energy, and especially natural gas, for all the reasons that we've been talking about today. So really, I'm coming at the angle of attack of research and development. And what we do in academic research is we're really trying to uncover new principles and new designs and new processes, things that are not necessarily going to be implemented in the next couple of years, but things that could be absolutely game-changing in a more maybe 10 or 20-year horizon. So we're trying to build up those foundations and really try to come up with unconventional routes, I would say, to do a lot of the things that we take for granted today conventionally. So on the research and development side, I've got a team of 24 right now that are focused in these general directions. And of course, as an educator at Stanford University, that would be the other, my other angle on this is that these energy problems are going to be here for a very long time. We have a lot of challenges ahead of us. And of course, we need multiple generations of talented scientists and engineers to tackle these, not to mention the other disciplines, of course. But in chemical engineering, that's also part of my mission to help develop the next generation of talent.
Okay, well, terrific. So if we roll the clock back 10 years, we were in a situation where we were thinking about building import terminals for LNG. And I think really no one can imagine what really happened is that instead the shale gas revolution began. And since that time, the amount of natural gas that we've produced has gone up significantly. And it's had big effects on the economy. And as we look to the future, the prospects for stable, low-cost gas also offer continued opportunities. So what I'd like you to do is talk about some real examples of those benefits that we've seen and what are the benefits to come. And to start this, David, perhaps you could give us your thoughts.
Sure. Thanks for the introduction on that, Sally. Yes, when the U.S. hosts the World Gas Conference in June of 2018 in Washington, it'll be the first time that this conference has been held in a country that's both the largest producer and the largest consumer of natural gas. So that's a major achievement. And I can tell you from my travels around the world that our energy supply portfolio, not just gas, but everything that goes into that, is the envy of the world. And it's quite a competitive advantage. And when we look at the uses that natural gas goes into, perhaps one very clear way to highlight the advantages that we have because principally of the shale gas revolution is industrial activity. The American Chemistry Council came out with a report just last month outlining 225 new plant investments that are being made in the chemical and petrochemical space, totaling almost $160 billion. So that's huge investment, huge jobs, huge benefits and balance of trade, and really a great story. And in my travels around the world, I happened to be in Germany just a few months ago, presenting at their German Gas and Water Conference, and this topic came up, and I did a little homework on that, and of those 225, there are 11 German facilities that are being either picked up and moved or shut down and installed in our Gulf Coast principally, with BASF having about half of those. So not only are we seeing just benefits domestically in positioning us for greater impact in the global economy, but we're actually seeing migration of jobs and of capital from developed and developing countries to the U.S. based on our competitive advantage in energy.
Well, that's terrific. Michael or Tom, do you have any other thoughts you'd like to add, some examples?
Yeah, I'll go first and then you can go. You know, I think the story about the North American shale revolution was, well articulated by the previous panel and is known to everyone. I think what's kind of interesting, at least to me as I think about it, is, where does it go from here in terms of this in the environment, that's going to be not the one that we thought it was going to be 2 or 3 years ago. And so I think some of the, the interesting things that are happening, the discussion on, much lower structural cost in the industry, much more innovation, focus on kind of smaller, modular, flexible solutions, the focus on, how can you take this feedstock and move it in between its various uses. I mean, this is all really interesting area for technology development. I'd say the one big thing that I'm kind of watching as we look at, how sustainable is the shale revolution, is one that, the very positive story we just heard on the environmental attentiveness and just making sure that gas remains the clean fuel or a cleaner fuel. And then two, are you going to see sustainability in these productivity gains out of places like the Marcellus and Utica? And my sense is that we're going to be pushing it to the limits over the next 2 to 3 years. But then as you start to grow these markets around, the LNG, the export markets, the natural gas liquids, a lot of people are not maybe fully aware, but one of the big benefits of the North American Revolution is all these ethane, propane, butane feedstocks, a lot of new opportunities in these wet gases, if you will. And so I'm really interested in if we can sustain the productivity gains and you can sustain the kind of pricing levels that we've seen in the face of what's going to be a big shift from coal to gas, that is policy driven, and then also necessary for the renewals balancing and that sort of thing. And then also, into these LNG and demand sectors. So, this is, I think that's the most interesting thing for me right now is how will that technology pace continue, and how will the productivity gains, will they be able to be sustained in this tough environment?
Great. I'd like to add a couple of thoughts on starting with some of the things that David was talking about, and really the chemical sector, and just to put some numbers on this for everyone's edification. I mean, you hear the word chemicals by and large in the public. They hear that word and they might respond negatively to it. But these are all the things that we need. Fertilizer for food, ethylene to make polyethylene for milk jugs. I mean, the products are everywhere. In fact, there are 70,000 different chemical products that are produced globally. The United States produces about 1.2 billion tons of chemical products per year, and that reflects a market value of about $750 billion per year. North America is about $850 billion a year total. So this is, these are not small potatoes by any means. And the point I want to get at here is that the three big cost drivers in the chemical production industry are fuel cost, electricity cost, and feedstock. And natural gas hits on all three of these things. So this is why I can expect, and we're already seeing it based on things that David was just talking about, a resurgence here in the industry. By the way, the U.S. Also supplies, another number to bear in mind is 15% of the global chemical market. Now, that's the kind of conventional sectors. As I mentioned earlier, we're really interested in my lab on developing new technologies, kind of new ways of using natural gas. And the point is that years ago, if you were to develop new technologies that use natural gas, it would seem like you're just siphoning it from the conventional industry. But we're not in that situation anymore. And so there's going to be more natural gas that's available, which means that you can continue to do the conventional things and maybe do some unconventional things as well. And so in fact, in the class that I'm teaching this quarter at Stanford, it's an introductory energy engineering class. And I had every single student as their first homework set to get their home energy bills from their parents, and look at the three major costs that are involved in running a home, which is natural gas for heating, and electricity and gasoline, and do some analysis there. And so basically every household has a pretty significant chunk of money going to each of these three areas, but the amount of energy is actually quite different because the pricing is quite different. And so what I'm getting at is there might be some other ways than having a feed line of natural gas and a feed line of electricity and then going to fill up your car at the gasoline pump. And so one of the technologies, for instance, that we're working on right now is we're trying to develop technologies that can convert methane in natural gas to methanol by means of an electrochemical process, which, by the way, gives you electricity out. So it turns out that methanol is thermodynamically downhill from methane. And so our conventional process of methanol is a major chemical product, 100 megatons a year or so. And because we haven't engineered that process as well as we can, we basically take it from methane, very high energy content, all the way down to carbon monoxide or carbon dioxide, to then throw hydrogen at it and build it back up. And energetically, that's the equivalent of you being on the 8th floor of a building and you want to go to the 6th floor, and you decide you're going to go down to the 2nd floor or the ground floor first and then go up to the 6th. And that kind of makes no sense, but that's kind of how we do it because we know how to do that. So this is a process where you go straight from the 8th to the 6th. You get that energy out as electricity. So imagine, dream with me for a moment. You have natural gas going into your home. You have a device that takes that natural gas in, it produces electricity for you that you know you can rely on 24/7, 365, and you create methanol on it, and then that methanol is now a liquid fuel that you could make an internal combustion engine for a car, no problem, or run a fuel cell off of methanol, and that can give you the same range that we exist and enjoy today. So these are the types of unconventional processes, unconventional technologies that one can possibly develop. How close are we to this? It's not going to be next year that we commercialize such a thing. We're trying to build those fundamental groundwork so that we can make that a reality, hopefully in a few years from now. We'll see.
Okay, terrific. It was interesting. One of the things that none of you really mentioned was that natural gas is the cheapest way, natural gas combined cycle plants, the cheapest way to make electricity today. And of course, that has economy-wide effects. So anyway, lots of examples of benefits. I want to move on to another topic. And this goes back to the conversation we've been having about climate change and needing to reduce global emissions. And the question is, does natural gas have a role to play in a post-COP21 or post-Paris conference world? And I'd like your thoughts about that, and maybe Tom will start with you.
Yeah, great. And this is, in fact, exactly where I wanted to bring up this point that you were just mentioning. Let's get right back to it. I mean, well, actually, maybe we zoom out for a second. Post-COP21 world, what does that mean? Aggressive targets to try to prevent climate change, try to keep the climate to within 2 degrees of where it originally was. That is extremely ambitious, and I think we all know that, but I'm much happier with overly ambitious goal than the opposite direction where it's not ambitious enough. Having said that, how are we going to get there technologically? I think to pull that off in the very long run, you have to be mostly renewables, and the fossil fuel segment cannot be very big. It has to be much smaller than 50%, I think, to hit that sort of level. So certainly lots of tech needs to be developed on the renewable side. But that's 40, 50, 60 years out. Let's see where we are. What can we do today is really the pertinent question. And if you look at all the industrialized nations that are big emitters of CO2, the United States has already proved it, that over the past 10 years, our CO2 emissions have actually gone down. The GDP goes up, our CO2 emissions go down. We were projected to be emitting these days about 7 gigatons per year. Now it's only about 5.3, so that's a pretty large delta between where it kind of should have been based on projections from 15 years ago and where we actually are. And I think that's the blueprint. It's because natural gas is inexpensive, it's available, it's abundant, it's scalable. We can make really good power plants, combined cycle plants, 60% efficiency and up. And it's also regionally located, distributed around the world in a lot of different places. So it's not like only a few can benefit from all of this. And so the point being is, there are really not a whole lot of options. It's kind of a fuel mix argument. This is exactly, again, what the United States has been doing in recent years. We've seen the benefits, and I think that's the biggest role that natural gas has to play in a post-COP21 world. I think it'll be huge. Now, we do have to remember that it still is a fossil fuel at the end of the day, and there's also the methane leakage that we were talking about in the previous panel and earlier today, too. So, given that methane is 20 times as potent a greenhouse gas problem as CO2 on a 100-year time scale, that basically means if we're leaking 5% of natural gas while we do everything, it's just as bad as coal, and we certainly don't want that. So, but thankfully we heard that there's a lot of progress being made on minimizing those leaks, and so I do think that natural gas will play a significant role.
Okay, David.
Perhaps another dimension on this as well to provide some color to this. As we're sitting here, every year about 7 million people die prematurely from poor air quality. Maybe half indoor air quality, half poor air quality in megacities and the like. It's an extremely important challenge, big problem, and something that natural gas can fix today. And it's not inconsistent with the long-term view of reducing carbon emissions. So at COP21 in the middle of the week, we introduced this report. It was done by Jason Bordoff of Columbia that looked at case studies of 4 megacities around the world: Istanbul, New York, Toronto, and the early work being done in Beijing to better understand the role of natural gas in improving the air quality and the subsequent health benefits. So it's something that IGU is hitting on very strongly over this year. We were talking about that earlier. It's going to be one of the key messages. It's consistent with long-term addressing climate change concerns, but it's a critical need in these megacities, particularly in the developing economies, that are increasing in population, increasing in urbanization, and something that we just have to get at today.
Well, let me make a couple comments on this. One is anecdotal. It was really interesting. I think last year, if you looked at the top 10 cities with pollution, I was shocked to see that China cities weren't even in the top 10. It was all these India, Qatar, Pakistan, Islamabad, and it just tells you the scale of the problem with air quality. I spent a lot of time working on issues like flare gas reduction and trying to implement it in those kind of markets. And often the big issues in places like Nigeria, it wasn't about CO2. It was about the methane creating acid rain, which would hurt the water and then hurt the fishing, and then of course the guys would want to get guns and stop it. So these are real serious issues about taking care of those externalities. But I think one of the bigger things is gas is a pragmatic fuel, and some of these views are a little more my own than a GE view, but I see, the world that General Hayden described as one of being much more dysfunctional. And do you really think that we're going to be able to mobilize the capital to put giant socialized, grids across the, big parts of the world? Maybe, I'm hopeful. Things like Grand Inga, are ideal if we could do it in Africa. But those are $40 billion investments, that huge public-private partnerships. Those kinds of solutions are an incredible challenge for us. So, if you try and figure out where gas fits in between in terms of putting points on the board, getting stuff done, I think you talk about flexibility to serve multiple markets. You talk about scalability to go city scale, to serve countrywide solutions, to do stuff at industry or even village scale. Gas can do all those things. So, I'll talk about some of that a little bit more, but to me, one of the things you're watching is technology lock-in, right? In Indonesia, in China, they're going to be building these coal plants 30, 40 years. And until you get them some type of movement into at least a broader spectrum in their energy matrix, you're going to lock that technology in. So I would say there's an ideal mix. So maybe there's places where you've got too much gas. You actually have to move into, other baseload fuels, more renewables. Whether it's 30, 40, 40, or, but there's going to be some optimal mix of renewables, flexible technologies, and then baseload technologies. And, you've still got 1 billion people that have no power, right? And so it's kind of, a little solar panel's good, but having an entire city lit up so that they can be part of the modern economy is important too. So that's just a few comments.
Okay, good. Well, I'm going to bring up one other benefit that we see. So I live in California, and if you kind of weren't paying attention in California and you sort of one day opened up your app, it's called Cal ISO Today. It's my favorite app. Anyone can find it. It's our California Independent System Operator makes this available. And you can turn it on. And what you find out on a typical day when the sun is shining, that we get about 1/3 of our electricity from renewable sources, and about 5 to 6 gigawatts of our power is actually coming from solar. So that's fantastic. But it also creates a lot of problems, right? Because, it's 6 o'clock in the morning, it's still dark. All of a sudden the sun comes on and you quickly ramp up. You've got all this solar power. It stays on pretty much all day, but then the sun goes down and it rapidly drops. Well, in reality, how people use power is that we need power in the morning, and then it kind of levels out during the day, and then we need more power at night. And so this big solar resource is actually creating a lot of challenge. We call it the duck curve in California. I'm guessing we might hear about it later. And it's really gas turbines that have the capacity to turn on and turn on fast enough to make it so that the independent system operator can make all the pieces fit together. So my view is actually there's a tremendous synergy where natural gas is really enabling to adding more and more renewables onto the grid. And in Ireland, they have times where they have 70% renewable power, and which is more wind over there. But really, it's the natural gas availability to ramp up and down that has enabled, this huge penetration of renewables over in Ireland. So, okay. So let's move on to the last topic that we plan to formally talk about. As you were mentioning, there are many parts of the world that have no power whatsoever. I was in Pakistan last week, and the power is on for an hour, off for an hour, all day long, all day night. And what happens is that if you're wealthy enough, lucky enough, you have your own diesel generator, and you'll hear it ramps up and on and off and so forth. And there really is a huge challenge for power in the developing world, energy in the developing world. And you can look at places like Pakistan or whatever, and they need between 5 to 10 times as much power. The situation with cooking fuels is really abysmal. People are burning solid fuels, dung, wood, coal inside their homes. The air pollution is horrible. The women and children are most exposed. And it causes real problems. So the question is, in this age of natural gas, what is the role of natural gas in trying to alleviate energy poverty? And Michael, perhaps you could lead off this discussion.
So, one of the big themes from our power business, and for those of you familiar with GE, we have oil and gas, power, energy management, T&D, a lot of the different energy business, as well as the transportation and capital sides of the business. But from the power business, one of the big themes is this idea of powering everyone and utilizing the technologies to their ultimate optionality and flexibility. When I kind of look at this from a gas perspective, and we try and figure out, how are we going to go after some of these different markets? It's about finding the right type of mechanisms in each of those markets to let gas do what it needs to do. Essentially what I'm trying to say is some markets are interested in base load gas supplies or really attaching a gas resource to an end use and feeding those markets at a big scale. But what I'm really seeing out of the market is this mid-merit or this need for gas to fill this flexibility role against against hydro resources that are variable in Brazil or a lot of Latin America. In Africa, Nigeria, 7-10 gigawatts of power, 70 million people, 5x, 10x types of multiples of growth. Myanmar, similar kinds of stories. Pakistan. And so what we have to do is find, the combination of how do you get local enough in those markets so that you can work with the state-owned entities, bring the technologies to them, get the training in place so that you can advance these projects in kind of an institutional or in a large basis. But then how also can you do project finance and those types of things? So the overall market right now is interesting, right? A lot of things that we were doing early on for miners and others that were based on oil substitution are struggling in the market today. But if you take the view that oil is a cyclical commodity, we want to be ready with gas systems that can be deployable in 2, 3, 4 years. And that'll cut across a lot of different scales. A couple of the initiatives that we're really working from gas to power this year that are quite interesting are, one, this idea of mid-scale LNG to power. And what you see a lot in the LNG industry, the big traditional LNG industry, is these huge. So what's happening in LNG? 100 million tons of new flexible LNG is going to be on the market because this previous wave of investments in places like the U.S. and in Australia. The market is at a turning point, so in terms of availability of supply. But we have to figure out how to get that into these markets. And what you're seeing is it's very hard to find 2 or 3 or 4 gigawatt types of opportunities where you can get it all lined up and make it happen, multi-billion-dollar investments. We're really looking at, can we find a gas solution that fits in, say, an LNG solution that fits in, say, this 300 megawatt to a gigawatt range, or even to 1.5 gigawatt. We can use the brand new HA.2 technology, 62% efficient, super flexible in meeting these markets, very capital efficient as well, but trying to wrap the kind of regas and midstream solutions and then packaging it in such a way that we can get it completely financed, backed, and done, is a really interesting space. If you take it one step smaller, this is even a more interesting space, is that there's a huge abundance of natural gas liquids coming out of the U.S. I alluded to it before. LPG, propane. High-grade propane can be put into our aeroderivative turbines and into some of our F-class turbines in such a way that you can run diesel straight into propane, straight into LNG. So what we're trying to sell is an optimization solution. Start on propane. We'll get you up and running in 12 months or less. And then you can close the cycles on those turbines, move your efficiencies from the 45s into the 55 range for this, say, 150 megawatt to 300 megawatt solution, and then move into LNG. So you're essentially moving down the cost curve, moving up the efficiency curve, and getting a real nice life cycle fit, so you're not having to bank on a single fuel. This is a huge opportunity in Africa, in the Caribbean region, in parts of Southeast Asia. We see this LPG to LNG opportunity as a really interesting one to push. It's just happening today, and it's on the back of what's happening in part because of the North American shale revolution. We're not doing it alone at GE. We'd work with partners in the fuel chain. We would work with investors. We would work with local parties, and that's the whole idea around the initiative. One of the last ones I want to touch on before I close this is around solar and the role of gas with renewables. One of the more interesting things that we're also doing is looking at gas and solar hybridization, where essentially we can use our gas engine technology and use that to back up solar so that you can solve exactly the problem Sally mentioned, 24/7 solar in remote locations, not at the village scale, which is, kilowatt, but at like a 5, 10, 15, 20 megawatt type of range, but in remote. And so any place where you can really displace diesel or even take an existing diesel network and supplement it with an LNG network. So these are really exciting places in the gas industry. And so to get stuff done in these markets, you need to be really creative in partners. You have to take a little more risk to get these things done. And this is really the challenge to the downstream and midstream industry, is can we get innovative enough together to actually get these things moving in the market? Because there is a very high probability that in this kind of down market, everybody just digs in and it stagnates. Gas industry stagnates, and coal plants will continue to get built and built and built. And we've got to find a way, a Western solution really, to kind of advance these things at multiple scales. And that's one of the things that I'm really excited to be a part of, and why I think this whole idea of gas to power may be one of the most important things that I'll do in my life, is driving these types of projects around the world. So.
Okay. David, yeah.
Yeah, I just wanted to touch on something that perhaps helps countries make those kind of decisions, Michael, that you just mentioned. Natural gas is a way to sort of democratize energy, to get more of it around and enhance access. And I wanted to use as an example Mozambique. And the IGU that I mentioned before has partnerships with the UN and the World Bank to help them sort of figure out strategies for natural gas. So here you are in Mozambique, and you've just discovered huge quantities of gas. Actually, Brad Hawley's company, Anadarko, is out there somewhere, did it. So what we did, and by the way, then you have a choice now. You can quickly build an LNG plant and export all that to China and India and make a quick buck, or you can perhaps do both, but you can figure out a way to integrate that new resource into your economy through power generation, through heating, for cooking, et cetera, and actually raise the standard of living for your citizens by incorporating that new resource. So we organized with the World Bank and the UN a gas competence transfer seminar sponsored by Anadarko to do just that a few months ago. So it's sort of tackling this challenge, sort of one bite-sized market at a time, but it's something that we hope we can replicate to help bring more affordable energy, to the developing economies.
Yeah, I mean, a lot of the developed world will figure it out. They'll find the balance. It'll be whatever they can. We're smart enough. We have the institutions, the resources behind it. But in a lot of these emerging markets, you really have to put the whole package together. I mean, in some things, it is going to be run by the state. And so the best thing for a company like GE to do is just sell the best equipment we can to them and services and those things. But in a place like Mozambique, I mean, my impression of Mozambique is that you've got everybody coming out there offering a multi-billion-dollar, project that this is the thing that you need to do. And, maybe we just need to cut that, to 200 million and just get something done. Use a little piece of the gas. Now, some of it, one of the ideas in gas is that you have to have anchors in this idea of satellites. So you do need a big LNG plant to start the ball rolling. Big anchor infrastructures are critical to do anything else at a domestic basis. But it's going to be one of the, in a down market maybe for upstream investment, the growth of these smaller markets, these somewhat insulated domestic markets and growing gas there is going to be really an interesting opportunity space over the next five years for technology, for investors. There's some real investable thesis around that, depending on how you look at the forward world in terms of commodities and oil and stuff.
Okay. I think we're going to jump to some questions now from the audience, and I'm going to just give one to each of you, and you need to think of these as your last remarks. So I think I will start with David. And I hope I picked the right question for you. Anyway, will North America become a major LNG exporter?
Yes, the short answer, I think there will be a significant exporter. The next big tranche of LNG capacity is, of course, coming out in Australia, which is adding perhaps 25% of the world's capacity over the course of the next couple of years. Then the next big tranche will be the U.S., with about 6 facilities under construction right now. The first one, Cheniere in Sabine Pass, Louisiana, will be shipping almost any moment now its first LNG shipment. The global market will eventually dictate how much we actually ship and what our contribution is to the global market, but it's going to give continents and countries options. So I think we will become a major provider. We'll be part of the mix, and someday it could be perhaps 20% of our total consumption would be the equivalent thereof being exported to other markets.
Okay. All right, good. Second question. So this is for you, Michael, and you need to be quick. Can Western energy companies understand the cultural differences in the developing world in such a way that we can really effectively transfer some of the more advanced technologies you're talking about into the developing world?
Well, you have to know what fits for those. Yes, but it is something that you have to be careful. I mean, when we go into part of GE is this global growth group where we'll go in and it's a place where we'll do localization, and you have to get embedded in the region. You have to work with the local players. It tends to be a place where you have to be a bigger actor to really affect change and kind of understand how to run the traps. I mean, we're going to go into these places because 70% of the growth in energy demand is going to be outside of the developed world. 70, maybe even 80%, for all these things. So a company like GE that is an industrial company, we're going to have to be out there. We're going to figure out a way to compete in these markets, to create solutions in these markets, to leverage the technology suite that GE has in ways that, as a system integrator, as a financier, sometimes as a developer so we can learn how to do these things, and then later as a manufacturer and an implementer in the region. So we can get out there. Some places, every place is different, but when you look at Southeast Asia, Africa, Latin America, huge potential for us to make difference.
Okay, terrific. Okay, Professor Jaramillo. Okay, this is a tough question. You suggested that you were increasing your focus on fossil fuels. Is this more balanced approach happening across academia, or is it more isolated? And you will have the final word.
Wonderful. I think that I think it is a general trend that people recognize that there are 2 timescales for solutions. There's longer term and there's shorter term. The fact that energy operates at such a massive scale with the 18 terawatts that we're using right now, this very moment means that even if you were to develop the perfect solution for energy today, it would take a very long time, order decades, to really put a significant dent into those 18 terawatts. And so the point is, but you can get technology to work, you can get that scale to work in your favor if you work on more conventional technologies. And if you can make that 18 terawatts be 1% more efficient, that's actually not a small amount of energy. And so I think if you can balance that approach of short-term and long-term, I think that's going to get us where we want to be, because we can't just wait for these wonderful renewables to just come on stream whenever they come on. I think we do have to be acting sooner. So I think for my personal case, it's recognizing that we need some short-term solutions in addition to the long-term. And I'll also say that this is a growth in my group. It didn't detract from our work on the renewables in any way.
Okay, well, thank you very much.
Thank you, guys.